Let's talk about geometric sequences. A geometric sequence has a common ratio between each term. That means between terms you can tell something's being multiplied or divided, and of course it stays the same amount between each term. So two examples of this would be the sequence 1, 3, 9, 27, and 81. Each one of those steps in that sequence multiplies by 3. So we would say a sub 1, our first term is 1, and our common ratio r would be equal to 3. Another example could be 1/2, 1/4, 1/8, and 1/16. So between each term, you are multiplying by 1/2. So it's actually getting smaller, but your denominator is getting larger, but it's getting smaller. And so you can tell your first term is 1/2. Common ratio would be 1/2. You can also think of it as dividing by 2, because you really are dividing by 2 between each one also. So there are two forms for geometric sequences, just like there were two forms for arithmetic sequences. The recursive form is still the more straightforward one. You need the common ratio to find the term after the one, or excuse me, you use the previous term to find the one you're looking for by multiplying that by your common ratio. So a sub n is still just any term in the sequence we're talking about. A sub n minus 1 is the previous term, and r is your common ratio. So similar to arithmetic form, you would just take the previous term, multiply by that common ratio to get the one you're looking for. Explicit form helps us find any term we need. So a sub n is equal to a sub 1, the first term, times the ratio, and then in the exponent you have n minus 1. So that is an exponent. So a sub 1 is the first term, and this little n is the number of the term that we're looking for. Let's look at an example of this type. So using the given data set, write the correct sequence recursively and explicitly. So our example we're given is 4, 8, 16, 32, 64, and 128. So hopefully you can see that we are multiplying by 2 each time. We'll write that in each time. We want to make sure all terms get multiplied by 2 to make sure there's no exception. For your recursive form, you can find any term using that ratio. So we just need the r would be equal to 2, and we could write out recursive form would be a sub n would be the previous term times 2. So very straightforward. Again, it's kind of like your now next. Your next term is equal to the one you have now times 2. So that might look familiar. Your explicit form uses the first term and your ratio to come up with this form. So our first term we were given was 4, and our common ratio is still 2, and we would write out a sub n equals 4 times 2, I would put it in parentheses, and then we're going to have n minus 1 in parentheses, and that would help us find any term we need. Here we want to determine if the sequence is geometric, and if so, find r and write it in recursive form. So these are pretty straightforward. Let's look at this one. We have -2, -4, -8, -16. Is that multiplying each time? Yes, it is multiplying by 2. So let's put r would equal to, and my recursive form is a sub n equals a sub n minus 1 times 2. The previous term times 2 gives me the one I'm looking for. Let's look at the next one. -1, 6, -36, 216. So this one is multiplying, notice, by a -6. So my ratio is -6. So I would write out a sub n is a sub n minus 1 times -6. Notice it's very simple, very straightforward for recursive form. For number 3, we have -1/3, -1/9, -1/27, and -1/81. So this one stays negative. So we're not multiplying by a negative. Notice that one switched signs each time, so you can tell that it's a negative that's happening right there. But here, we're just multiplying by 1/3 each time. And it's getting smaller. So r equals 1/3, and a sub n would be a sub n minus 1 times our common ratio of 1/3. I'm going to prop that up a little better. Number 4, we have 4, 16, 36, and 72. So 4 times 4 would give me 16, but 16 times 4 does not equal 36. So that puts a detour in the plan. So that would need to be 64, but that's not the case. So this one is not geometric. So in this case, we can stop right there. Let's look at one more board. This one, we want to find the term in each geometric sequence. So again, we could be given some sequences or given just information about the sequence, and we can use explicit form for each one of these. So the 10th term given this sequence, I need the first term is 2. Remember the explicit form, I'll write it up here, was a sub n is the first term times the common ratio, and then your exponent was n minus 1. So we're going to be just filling that in. A sub 1, our first term, was 2. So I'm going to put any term in this sequence would be the first term times the common ratio. See what's happening there? It's multiplying by 4 each time. I like to put it in parentheses. And then n minus 1 is my exponent. It's a little crowded, but it'll be all right. So the 10th term means a sub 10 equals 2 times 4 to the 10 minus 1 power. And to save time, I've calculated that one. It's a big number. A sub 10 equals 524,288. Big number. Okay, let's look at the next one. The 9th term in this sequence, so we check out what's happening. We have our first term is 1,000. The common ratio, it's getting smaller. Looks like it's dividing by 2. So we write that like it's multiplying by 1/2, so it looks like a ratio. So let's set up a sub n would be 1,000 for our first term times 1/2 and then n minus 1. And then we want to fill in the 9. So the 9th term is 1,000, 1/2, and then 9 minus 1. And then I've already calculated to save us some time. And that gave me 3.906 approximately. It was a decimal. They're getting smaller. So let's look at the last one. The 15th term in this sequence, they gave us the first term and the ratio. So we can go right to the explicit form and put the first term, put in the ratio. We've got n minus 1, so we want to find the 15th term. And you can do that part in your head, of course, and just put 14, like if you were typing this in your calculator. No problem with that. I'm just writing it out. So I did this one ahead of time, and it is 34.25. So like I said with arithmetic, these are some examples of what they could ask you about, but there are definitely more questions they could ask. But use